All right, so let's go to the code examples for today. All right, so you can open up day 5 examples.mlx, download it from the module. The first part is just a review of what you covered in 1181, how relational operators work on scalars. And so I'm going to go through that very fast, because most of you've all seen it before. Most of you probably remember it reasonably well. Just hit a couple of important points. One is, remember that when you're comparing two things to see if they're equal, you use a double equal sign. Okay, so a single equal means assign this value to that variable. A double equals means you're asking the question, are the two things equal? And that'll give you a true or a false, or to put it in other terms, a logical 1 is true or a logical 0 is false. So here I got a 1 because 15 is equal to 5 times 3. Here I got a 0 because pi is not exactly equal to 3.14159. So you have to be careful with floating point numbers. That is a number with a decimal point. You never want to check for them to be exactly equal because there's always round off error. So normally with floating point numbers, what you do is something like this. You ask, is the absolute value of the difference between the two less than some small tolerance? If it is, then you judge them to be equal. Okay, so, and how small does this have to be? Well, it just depends on the specific problem. But in this case, I'm saying, well, if the difference between the two is less than 10 to the minus 6, I'm going to say for all practical purposes, they're equal. All right, you can also do a not equals. It's easy to get the logic mixed up in your head when you're using not equals, but you're asking, is it true that 15 is not equal to 5 times 3? That is not true. They are equal. So when I ask if they're not equal, I get a false. Right? Is it true that pi is not equal to 3.14159? Yes, that's true. They're not exactly equal, so I get a true. And of course, you can do less than, greater than, less than or equal to, greater than or equal to. And just one little detail to keep in mind, if it's when you're doing less than or equal to or greater than or equal to, it has to be in this order. Less than, equal. It can't be the other way around. All right, so is the cosine of 30 degrees less than or equal to 1.732 over 2? Cosine of 30 degrees, by the way, is the square root of 3 over 2. And the square root of 3 is about 1.732. In fact, it's a little bit more than that. So when I do this comparison, I get a false. Is it true that pi is less than this? Yes, it's 3.1415926 something. So it's a little bit less than this, so I got it true. All right, so for these first examples, I just used numbers. Of course, you can do this with variables also. You can compare a variable against a number, or two variables, or two expressions involving variables. And so here's an example where we have a variable x, we set it to 0.1, and we ask, is x greater than or equal to x squared? Well, because x is less than 1, that will be true. Okay. Now, here's a funny thing you can do in MATLAB that you might not be able to do in other languages. But you can mix these relational operators with arithmetic. And what it will do, each one of these relational operations evaluates the true or false, which is a 1 or a 0. And then it will just put that number, 1 or 0, into the arithmetic expression, which in this case means it's just going to add up the ones. Right, so I got a 3. So what that's telling me is of these expressions that I put here, 3 of them are true. And so this can actually be a powerful technique for analyzing data sometimes. But you have to keep in mind, if you're going to do this, the relational operations have to be enclosed in parentheses, because the arithmetic operations actually have a higher precedence. Like there's a chart here, which I actually copied from 1181, showing the order of operations. You can see the arithmetic operations come before the relational ones. So if I don't put parentheses, it's going to do the arithmetic first and then do the comparisons. Right, so this shows you step by step how it would do that. Okay, so first it does 1 plus 7 is 8, 10 plus 8 is 18, 9 plus 8 times 10 is 89, and 5 times 16 is 80. Then it evaluates the relational operations from left to right. So is 0 greater than 18? No, so it replaces that by a 0. Is 0 not equal to 89? Yes, that's true. So it replaces that by a 1. And then you end up with, is 1 less than 80? Yes, it is. So finally, you end up with true or logical 1. Right, so when I run this, you'll see every step gives me the same answer, 1. Because all of these expressions are equivalent from here all the way down to here. All we did was simplify it step by step.